Let's take a look at Leet code question 155, the min stack question. And this is a great question to get familiar with the stack data structure because we actually need to construct a stack which adheres to the minimum stack method. Let's take a look at the question. Design a stack that supports push, pop, top, and retrieving the minimum elements in constant time. Implement the min stack class, where the min stack function initializes the stack object. Push pushes the value to the stack. Pop removes the element from the top of the stack. Top gets the top element from the stack, and get min retrieves the minimum element in the stack. And then there's also this part here where it says you must implement the solution with O of 1 time complexity for each function. And then there's an example here where you can see that you have a bunch of code that gets called. So you instantiate a new min stack, you push -2, you push 0, you push -3. You get the minimum, and then the minimum is going to be -3 because -3 is the smallest value out of -2, 0, and -3. And then you want to pop or remove these two, this element here, and then you get the top, which will then be 0. And then you also want to be able to get the minimum. So this behaves very much like an array, except for the fact that you need to keep track of the get minimum. And since we must implement each solution with O1 time complexity, we'll need to see how we can do that. So let's dive into the code here. So we have a class min stack, and we need to push some methods. So what we want to do is we want to create a stack, and this is going to be a private variable. And I'm going to have a value here, which is going to be the number, but this is in an object because I also want to keep track of the minimum number, because you can imagine if you have a stack, to be able to determine the minimum number, you need to know all of the numbers before it. And then if you have a minimum number, you want to be able to keep track of that for the particular stack value that you have. Because if you pop something from the top of the stack, you'll lose that information of the minimum value on the next new top. So that's why each stack needs to have a reference to the value and also the minimum number. And then this is going to be an array of these value and minimum numbers. So we can have a constructor, and this is simply going to initialize the stack equal to an empty array here. And then we can have our methods. So we have a push method, and then that takes a value, which is a number, and then it won't give anything back. So the push method, basically what we can do is we can work out the minimum value. The way we can work out the minimum value, and we do this before we push to the stack because a stack has a reference to the minimum value. Essentially what we can say is we can have a min value here, and basically this is either going to be equal to the value if there's nothing in the stack, because if there's nothing in the stack, it has to be the smallest value by default. But if the stack has a value, we need to determine if that is greater or smaller than the value, or perhaps equal to the value that was passed. So we can just actually take our stack, and if the length is greater than 0, we can simply use the math function, because the math function will be able to determine the minimum between the minimum value here, which we haven't created just yet, but we will in a second, and then a value. Otherwise, it will simply just be the value. And then we can push to the stack, the value and the minimum value that we've just created here. And then that's all we need to do. And we're going to come back and we're going to re-explain this line 7 here, after we create the methods. So if we want to pop something from the stack, that's quite easy to do because that's just an array method that we already have. So we can just take the stack and then we can call pop, and that will simply remove the top or the last element. So last in, first out. If we want to look at the top number, this is quite easy to do as well, because we can simply just look at whatever the last element is. So if we look at our stack and we take the length of the stack minus 1, and then I just change this to a square bracket here. And then we find the value of that, which is what we've called, this is what our data type is. They'll get the minimum value. Oh, sorry, they'll get the top value. And that's okay. And then we want to have this get min function, because this is a min stack, not just a stack, where we're keeping track of the minimum value. And the way we can do this is we can simply just return the stack, and we can also reference the top element or the last element in the array. And rather than looking for the min value, we can, rather than looking for the value, we can look for the min value. And essentially that's how we can implement our min stack. So just to recap that, and all of these work in O1. So let's recap that and see that. So starting with push, which is probably the trickiest part of this whole thing. Basically, to be able to solve this problem, you just need to recognize the fact that each time you push to the stack, each stack needs to reference the minimum number, because you need that minimum number to be able to get the minimum number and to be able to push an element to the stack. And then consequently, if you pop from it, you can see the previous minimum values that were already calculated. So if you recognize that, that's pretty much half the question done, because then you can simply just implement the solution. And if the stack length is greater than 0, you can take the top element, which has a reference to the minimum value. But if the new value that you're pushing is greater than or less than that minimum value, that will be the new minimum value. Otherwise, you just take the value and then you just push that. And then pushing is, of course, O of 1, because you're pushing to the end of an array. And then popping is an O of 1 operation. So you're just removing it from the end of the array. You don't have to do any shifting. If you want to do a simple lookup based on the index, you can do that based on the length of the stack. And you can look at the corresponding value, and the minimum is just looking at the corresponding minimum of the top value. So let's go ahead and submit this. And we see that we beat 90%. So that's really good. Thanks so much for watching, and I'll see you in the next video. Cheers.